In this lesson, we'll define the 6 trig functions. What I'd like to do, though, is to look at a function that you should be familiar with from algebra, y equals x squared, or in function notation, f of x equals x squared. We call this function notation, and in this lesson we really won't look at the trig functions using function notation, but eventually we will be graphing them just like you graphed f of x equals x squared. For function notation, we know that x is the independent variable, and we can choose any value, any real number we want, and square it, and that will give us f of x, or sometimes we use a y, which is the dependent variable. Sometimes we speak of this as input and output. In other words, if I want to let x equal to 3, 3 is my input. When I square the 3, my output, or my y, or my f of x, is 9. In trig, instead of using x's at first, and eventually we will use x's, for our variables we use Greek letters, and this happens to be the Greek letter theta. So this function would be read f of theta equals the sine of theta, and the sine is a trig function. Now what we want to do today is to learn how to find the sine of theta, what it means. In algebra, when you had to square x, you already knew how to square. So that wasn't anything new and different. But that's what this whole lesson is about, is if I have a theta, how do I find the sine of theta? And after all, what is theta? So let's first define theta. Theta is an angle. We call it angle theta, and it's the Greek letter T-H-E-T-A, pronounced theta. For our trig definitions, we are assuming that the angle theta is in standard position, and if you remember, standard position for an angle means its initial side is on the positive x-axis, and its terminal side is just wherever. And for this one, my theta's terminal side is in the second quadrant. Notice this point P right here on the terminal side of my angle theta, and I have given it generic coordinates x and y. So that's my angle theta. It does need to be in standard position. It truly could be positive or negative. This one, of course, is positive because it's generated in a counterclockwise direction. Now, before we define the trig functions, we need to define r. We define our r to be the distance from the point on the terminal side to the origin. So our geometrical interpretation is that r is the distance from the point P, whose coordinates are x, y, on the terminal side of theta to the origin, which of course its coordinates are 0, 0. Now what we can do here is, because we know that the coordinate, the x coordinate here is x, then what we know is that down here on the x-axis, that's what the x means. That's what it represents. And because y is the coordinate for this point, we know that if we draw a line that is perpendicular to the x-axis, and we'll denote that as a right angle, that the distance from this point P to the x-axis is that distance y. Of course, if you trace it over to the y-axis, you could see that there is your y distance. Since we have created a right triangle here, we know that by the Pythagorean theorem that if we want to find r, and notice that r is the hypotenuse for this right triangle, we know that the hypotenuse squared, or r squared, equals x squared plus y squared. The hypotenuse squared equals leg squared plus leg squared. And then if we extract roots, we know that r is equal to the square root of x squared plus y squared. Notice we only put the positive square root, and the reason is because r is always positive because it represents a distance. And the way that we state it is always positive, or state that it is positive, we say r is greater than 0. Now we define 6 trig functions, and here is the list of the 6 trig functions. These are the trig functions of theta with theta in standard position, a point on the terminal side whose coordinates are x and y, and whose distance, where the distance from the point on the terminal side to the origin is labeled as r. The functions are the sine function, the cosine function, the tangent function, the cotangent function, the secant function, and the cosecant function. We abbreviate the sine as SIN. We would read this as the sine of theta. We abbreviate the cosine as COS, and we would read this as the cosine of theta. For the tangent, it's TAN, and we read that the tangent of theta. The abbreviation for the cotangent is COT, and this would be the cotangent of theta. For the secant function, we abbreviate it SEC, and this would be the secant of theta. And for the cosecant function, we abbreviate it CSC, and this would represent the cosecant of theta. Now, what do we mean by these functions? Well, let's understand what the rules are here. First of all, xy has to be a point other than the origin on the terminal side of an angle theta in standard position. The distance from the point to the origin is r, and r equals the square root of x squared plus y squared. We define the 6 trig functions as ratios. They are ratios, and they're the 6 different ratios that you can get by using x, y, and r. The first ratio that we'll define will be the sine of theta, and it's defined to be this this y coordinate divided by the r distance. And for the cosine of theta, it's defined to be this x coordinate of the point on the terminal side divided by that r distance. For the tangent of theta, it's defined to be the y coordinate divided by the x coordinate, and obviously x does not equal to 0, because if it did, then this ratio would be undefined. Notice we didn't have to worry about that on the sine and cosine because their denominators are r, and r would never be 0. If r was 0, you wouldn't have an angle theta, so that was not a concern here. The cosecant of theta is defined to be the r distance divided by the y coordinate, where y does not equal to 0 because division by 0 is undefined. The secant of theta is defined to be the r distance divided by the x coordinate, where x does not equal to 0. And the cotangent of theta is defined to be the x coordinate divided by the y coordinate, where y does not equal to 0. Now write those down and memorize those. You are going to have to know those. I want to call something to your attention before we work a problem using these definitions. Do you notice any relationships here? For the sine of theta and the cosecant of theta, they are reciprocals of each other because y divided by r is the reciprocal of r divided by y. Likewise, on the cosine of theta and the secant of theta, they are reciprocals of each other. And also, for the tangent ratio and the cotangent ratio, they are reciprocals of each other. We won't use that in this lesson, but we will use it in the next lesson, and you might as well be aware of that. All right, let's work this problem. It says find the values of the 6 trig functions for the angle in standard position having 3, -4 on its terminal side. Well, I want to graph this theta. There's my initial side. To get the terminal side, let's graph this point 3, -4. And so there's my terminal side. Now I'm going to say that my theta is positive. It would not have to be. It just has to be in standard position with the point 3, -4 on the terminal side. It's obvious that my x in this case is 3. My y is -4. What I need to find is my r. And to do that, I'll use Pythagoras. R equals the square root of x squared plus y squared. So my r will equal 3 squared plus -4 squared. Remember, order of operation says under that radical to square first and then add. So 3 squared is 9. -4 squared is 16. When we add, we'll have the square root of 25, which is 5. So our r is 5. And I'm going to take my work away so we'll have room to find the trig functions. We'll start with the sine of theta, which equals y divided by r. That would be -4 divided by 5, or -4/5. For the cosine of theta, that's x divided by r. That would be 3 divided by 5, or we would just leave that as 3/5. The tangent of theta is y divided by x. That would be -4 divided by 3, which equals -4/3. The cotangent of theta is x divided by y. That is 3 divided by -4, which is -3/4. And notice our reciprocal relationships there. And now let's figure out what the cosecant of theta is. The cosecant of theta is r divided by y, which that would be 5 divided by -4, which we would write as -5/4. And I want you to notice something. Those are my reciprocals, right? And notice how they are reciprocals of each other. Let's see if I'm going to have room to do my secant. My secant of theta is r divided by x, which would be 5 divided by 3, or 5/3. Notice my reciprocals, 3/5, 5/3. Now that we have the definitions of the trig functions, we can calculate the trig functions of our quadrantal angles. Remember, quadrantal angles are angles whose terminal sides are on the x or the y axis by choosing a point on the terminal side. But there's something I want you to consider before we actually figure out what those functional values are. If the terminal side of an angle in standard position lies along the y-axis, any point on the terminal side has an x-coordinate of 0, and that's because all points on the y-axis have an x-coordinate of 0. What we would be referring to in this case, standard position, initial side on the positive x-axis, and if the terminal side was on the y-axis, that could be 90 degrees, that could be 270 degrees. It could be some other angles also, but today we're just going to talk about 90 and 270. So the x-coordinates for all these points is 0. Likewise, any angle with terminal side on the x-axis has a y-coordinate of 0. That would be 0 or 180, or if we went all the way around the terminal side on the positive x, could be 360. So any point that we chose, the y-coordinate would equal to 0. The values of x and y appear in the denominators of some of the trig functions. And since a fraction is undefined if its denominator is 0, some of the trig function values of quadrantal angles are undefined. Let's look specifically at the function values of these angles. We'll start with 0 degrees, which of course has initial side on the positive x-axis and terminal side on the positive x-axis, and there is no rotation. That's why it's 0 degrees. To get the 6 trig functions of 0 degrees, we'll choose any point we want to on the positive x-axis. Well, the one that I'm going to choose is the point 1, 0. So I know in this case x equals 1, y equals 0. I need to figure out what r is, but remember, r is the distance from this point to the origin. I can see what r is, can't I? It's 1. If you want to technically calculate it, we would say x squared is 1 squared plus y squared would be 0 squared. 1 squared is 1. 0 squared is 0. When we add 1 and 0, we'd have 1, so the square root of 1 is 1. I don't think you want to do that, but you see that we would get 1 if we worked it the long way. Now, when we decide what the sign is y over r, so that would be 0 divided by 1, which would be 0. So that means that the sine of 0 degrees is 0. For the cosine, x over r, that would be 1 divided by 1, which is 1. So that means the cosine of 0 degrees equals 1. For the tangent, y divided by x would be 0 divided by 1, which is 0. For your cotangent, x divided by y would be 1 divided by 0. And what's 1 divided by 0? It's undefined, isn't it? We don't know what it equals. So we write undefined, and we will abbreviate that as UND. For our secant of theta, that is r divided by x, so that would be 1 divided by 1, which is 1. And for our cosecant of theta, that's r divided by y, that would be 1 divided by 0, and that would also be undefined. So what we're doing here is we are using 0 in place of our variable. We are using 0 for input, and then this represents our output in this function. So the sine of 0 degrees is 0. The cosine of 0 degrees equals the number 1. The tangent of 0 degrees equals the number 0. The cotangent of 0 degrees does not equal a number, it's undefined. The secant of 0 degrees equals the number 1, and the cosecant of 0 degrees is undefined. Let's look at 90 degrees in standard position. Let's choose a point on the terminal side, and the point that I'm going to choose will be the point 0, 1. So my x equals 0, my y equals 1, my r, what's this distance going to be? 1. If you want to figure it the long way, go for it. So for my sine, it's y over r, which is 1. For my cosine, it's x over r, which is 0. For my tangent, it's y over x, which is undefined. Cotangent, x over y, which equals 0. For my secant, r over x, which is undefined. And for my cosecant, r over y, which equals 1. Let's look at 180. The point on the terminal side that I'll choose will be the point -1, 0. X equals -1, y equals 0, and what's r? It's that distance, isn't it? Be real careful here. Distance is always positive, so r equals 1. If you want to calculate it, and some of you I know need to see this, it would be the square root of -1 squared plus 0 squared, which -1 squared is 1, 0 squared is 0. When we add the 1 and the 0, we get the 1, and the square root of 1 is 1. So you can do it the short way or the long way. So if our angle is 180 degrees and we want to find the sine of 180 degrees, y over r gives us 0. X over r gives us -1. Y over x gives us 0. X over y is undefined. R over x gives us -1, and R over y is undefined. Okay, let's finish up the quadrantal angles by looking at the trig functions of 270 degrees and 360 degrees, and we'll summarize what we found. For 270 in standard position, choosing a point on the terminal side, I'll choose the point 0, -1, x is 0, y is -1, r would be this distance, which would be 1. For my sine, y over r equals -1. Cosine x over r is 0. Tangent y over x is undefined. Cotangent x over y is 0. Secant r over x is undefined, and cosecant r over y is -1. Note that the tangent of 270 degrees is undefined and the secant of 270 degrees is undefined. And of course, the reason for that is because for the tangent and the secant, x is in the denominator and the x coordinate in this case is 0. For 360 degrees, initial side, rotate, terminal side, looks just like 0 degrees except for the rotation, doesn't it? Since the terminal sides are the same, when we pick a point, of course we can pick any point on the terminal side, but I'm going to pick the same point on the terminal side, and it's pretty obvious then that the trig functions of 360 degrees will be the same as the trig functions of 0 degrees. You will see that as we work this out, but you need to be aware that angles that have the same terminal side that are in standard position also have the same trig functions. In this case, x is 1, y is 0, r is 1, that distance is 1. For my sine, y over r, I get 0. For my cosine, x over r, we get 1. For the tangent, y over x, we get 0. For the cotangent, x over y is undefined. For the secant, r over x, we get 1. And for the cosecant, r over y is undefined. And notice that for 360 degrees, just like for 0 degrees, the cotangent of 360 degrees is undefined, and the cosecant of 360 degrees is undefined. Undefined function values. If the terminal side of a quadrantal angle lies along the y-axis, the tangent and secant functions are undefined. That's because when the terminal side is on the y-axis, the x-coordinates are 0, and for both of these functions, the x-coordinate is in the denominator of the ratio, which makes the function undefined. If the terminal side lies along the x-axis, the cotangent and cosecant functions are undefined. And that's because on the x-axis, the y-coordinates are 0, and for these two functions, the y-coordinates are in the denominator, which makes those two functions undefined. here is a summary of all the function values for the quadrantal angles that we have just derived. Copy this chart down, memorize this chart. You are supposed to know these values. All right, let's work some more problems. This problem's a lot like that other problem that we worked, but maybe a little more challenging. Find the values of the 6 trig functions for the angle in standard position having -2, -2 times the square root of 3 on its terminal side. Well, first thing that I want to do is to graph this, and I will call this angle theta, and I'm going to put my initial side, and then for my terminal side I want to plot this point -2. Now when I get ready to plot this point, really to plot it I need to have an estimate of what this value is. So I'll calculate on my calculator 2 times the square root of 3, so it will be negative, and when I calculate 2 times the square root of 3 and round to the nearest tenth, I get that that equals -3 5/10. So that's what I'll use to plot this. -2 and then -1, 2, 3 would be about right there. So there's my terminal side. There's my theta, and I'm going to label my point. So my x in this case is -2. My y is -2 times the square root of 3. And I'm going to need to find my r. So let's do that, and we'll just write it. We'll use Pythagoras. We'll say r is x squared plus y squared, and -2 squared is 4. And when we get ready to square this, remember that when these are factors that we can square each factor, I would think -2 squared times the square root of 3 squared. Our -2 squared is 4. Our square root of 3 squared is 3. So what we end up with is 12. So 4 plus 12 is 16. So our square root of 16 will be 4. So in this case, our r is 4, and so what I'm going to do is just to write the 4, and then I'm going to move my work so we can find our trig functions. For my sine of theta, remember that it is y divided by r, so it will be -2 times the square root of 3 divided by 4. I will bring the negative out front, and I can reduce 2 divides into 2 once and into 4 twice. So I will have the square root of 3 divided by 2. For my cosine of theta, that's x divided by r. I'll have -2 divided by 4, which is -1/2. For my tangent of theta, that will be y divided by x, -2 times the square root of 3, divided by -2. Now what happens is those -2's divide to 1, so we're left with the square root of 3. For my cotangent of theta, my x over my y well, the negative 2's divide to 1, but I'm left with 1 divided by the square root of 3. Now, I'm sure that you remember from intermediate algebra or from some algebra that we just don't leave it like that, do we? So, what do we do? And I think I'll just write it down here. We call it rationalizing the denominator. We multiply both the numerator and the denominator by the square root of 3. 1 times the square root of 3 is the square root of 3. Of course, the square root of 3 times the square root of 3 is the square root of 9, but we know that equals 3. Now, I'm not usually going to put that step in, but I thought it might have been a while since you've multiplied radicals, and you might want to see it. Usually, I just say the square root of 3 times the square root of 3 is 3. So we would write this cotangent as the square root of 3 over 3. Now, let's see, I only have 4 of these, don't I? Be sure you know the 4 I found, because I'm going to have to cover this up. Sine theta, negative square root of 3 over 2, cosine theta, negative 1/2, tangent theta, square root of 3, cotangent of theta is square root of 3 over 3, and what I want to find then would be, it doesn't really matter what order, the cosecant of theta, which is r over y, which I'll bring the negative out front, and I'll say 2 divides into 4 twice and into 2 once. So we're left with 2 over the square root of 3, and once again, we want to multiply by the square root of 3 over the square root of 3, and in this case, we'll get negative in the numerator, 2 times the square root of 3. In the denominator, the square root of 3 times the square root of 3 is 3. So that's what our cosecant of theta would equal. And I think we need to figure our secant of theta, don't we? And so our secant is r over x. That would be 4 divided by negative 2. Positive divided by a negative is negative, and 4 divided by 2 is 2. One thing I'd like for you to look at, and I don't know if you will be able to see this on screen or not. Don't know if you'll be able to tell. It's hard to tell that these are reciprocals, but the one that you can see very evidently are reciprocals that's probably worth pointing out to you is your cosine and your secant. For your cosine, you got negative 1/2. For your secant, you got negative 2, and those are very obviously showing that reciprocal relationship. Let's look at another problem that's very similar. An equation with a restriction on x is given. This is an equation of the terminal side of an angle theta in standard position. Sketch the smallest positive such angle theta and find the values of the 6 trig functions of theta. Now, remember that what we have to find the 6 trig functions is a point on the terminal side, and then once we have the x and y coordinates of a point on the terminal side, then we can find r. So what we'll do here is first we'll sketch the terminal side, and we'll see if we can't figure out a point on the terminal side, and then we'll use that to find our r and our trig functions. So what I'm going to do to sketch this equation, I'm going to solve for y. I will solve for y. Let's take this. By adding 3x to both sides, I'll get negative 2y equals 3x and then I'm going to divide both sides by -2. So I get this equation in y equals, and a positive divided by a negative is a negative 3/2 x. So I've got that in slope-intercept. Remember that the -3/2 represents the slope of the line, and since there's no constant over here, that means that the line goes through the origin 0, 0. Now when I get ready to graph this, I can set up a table of values, but remember that x is less than or equal to 0, so we'll start with 0, and when x is 0, -3/2 times 0 is 0, and then I need to choose other values less than 0. So what if I use -1? I'll get that y equals -3/2 times -1, which is +3/2, and then I'm going to use -2, and when I do, I get that y equals -3/2 times -2. Of course, a negative times a negative is a positive, and then the 2's divide to 1, so what I get there is a +3. So I've got enough points, I think, to plot this. Let's see, -1, 3/2, and then -2, 1, 2, 3. So that's what the terminal side looks like. Let's I'm going to need more room anyway, so let's do a little better job of that. How about it? Let's see, I've got my 0, 0, my -1. Let's see, let's plot some. So -1, 3/2 would be 1.5, and then -2, 3, 1, 2, 3. And so here's my terminal side. Of course, there's my initial side. So first I was supposed to sketch theta in standard position, wasn't I? So let's see here. There's my theta in standard position. I could choose either one of these points, but it looks like to me that -2, 3 would be easier to work with than -1, 3/2. So I will choose that. You could choose other points too, just as long as whatever you substituted in for x, and let's just, for an example, look at -4. If I use -4, then y is -3/2 times -4, and of course a negative times a negative is a positive. 2 goes into 4 twice, so I get 6. You could just as well use -4, 6, and you might want to try that because it is important that you realize that you can use any point on this terminal side other than the origin. So I think I've got this sketched, and I don't think I need the rest of that problem, so I think I can find my trig functions of theta with this information. So let's see what I can do here. I know that my x equals -2, my y equals 3, and of course what I need to find next is my r. So let's find our r. We'll say -2 squared plus 3 squared. -2 squared is 4. 3 squared is 9. When I add, I get the square root of 13, and that's not a perfect square. So my r is just the square root of 13, and I'm going to move my work on my r. Now let's get those 6 trig functions. Let's get the sine first. it's my y divided by r. And I know that I can't leave it like that, so let's rationalize. So in the numerator, we'll have 3 times the square root of 13. In the denominator, the square root of 13 times the square root of 13 is 13. For my cosine of my angle theta, I'll have x over r. Once again, I get to rationalize. Let's bring that negative out in front, and let's say numerator is 2 times the square root of 13, denominator is 13. For my tangent, my y over my x, and let's write that as negative 3/2. For my cotangent, my x over my y, we'll write that as negative 2/3. For my cosecant of theta, my cosecant of theta is my r over my y. And I can leave that alone, can't I? And for my secant of theta, that's my r over my x. And we would not leave that negative in the denominator like that. We will bring it out front, and we'll write the square root of 13 over 2. So I believe you can see all 6 of those values. Once again, it's sort of hard to see the reciprocal relationships, except that you can see tangent theta and cotangent theta. Those are very obviously reciprocals. Now we want to look at a different type of problem, and what you're going to need to know to work these problems are the trig function values of your quadrantal angles. So you might want to get out that chart and look at it. We'll start by explaining what we mean by these symbols. We read this as sine squared of 90 degrees. And what we mean by this is that we want to find the sine of 90 degrees. We want to figure out what number the sine of 90 degrees is, and then we want to square it. So in that case, the sine of 90 degrees is 1, so that would mean 1 squared, which would equal 1. In general, when we write sine squared theta, and that's how we read it, we mean that it is the sine of theta squared. Another interpretation, of course, of squaring something, we mean that this is sine theta multiplied by sine theta. Now, we're not going to need to know that in these examples. We will need to know this, but you might as well pick that up from this lesson. So let's look at these problems. It says use the trig function values of quadrantal angles to evaluate the following. And this, when we read it, means the sine of 0 degrees minus 5 times the cosine of 180 degrees. When we write that 5 next to that cosine, it's understood to be 5 times the cosine of 180 degrees. The same way when we write 5x, we mean 5 times x. So what we'll do with these problems is we'll go through and figure out the function values, and then we'll use order of operation. So the sine of 0 degrees is 0, the number 0. So we'll replace this expression, sine of 0 degrees, with 0. Then we have minus 5 times. We're going to multiply that 5 by the cosine of 180 degrees, which is negative 1. So we'll have 0 minus 5 times negative 1 is negative 5. Order of operation tells us we want to do that multiplication first. And then, of course, subtract a negative is adding a positive. 0 plus 5 is 5. So when we evaluate this expression, we get the number 5. Let's look at the second one. This means 2 times the sine of 90 degrees squared plus 3 times the cosine of 360 degrees squared minus 4 times the tangent of 0 degrees squared. I think since we're beginners that I will just rewrite this. This would be 2 times the sine of 90 degrees squared plus 3 times the cosine of 360 degrees squared minus 4 times the tangent of 0 degrees squared. Now let's go through and get our trig values, and then we'll use order of operation. The sine of 90 is 1. The cosine of 360 is 1. The tangent of 0 is 0. So order of operation says square. 1 squared is 1. 1 squared is still 1, isn't it? And 0 squared is 0. And now order of operation says multiply. 2 times 1 is 2. 3 times 1 is 3. Minus 4 times 0 is 0. And then when we add 2 plus 3 minus 0, we get 5. I'd like for us to look at one last problem which really helps us to understand the next lesson on the signs of the trig functions in the different quadrants. So let's look at this. It says, suppose that the point xy is in the indicated quadrant. Decide whether the given ratio is positive or negative. So for my A problem, I have the second quadrant, so I could choose any point out here in the second quadrant. For no good reason, I'll just choose that point. Now for this point, what do I know about x and what do I know about y? Well, it's x is negative, isn't it? It's on the negative x-axis. I could say that x is less than 0. Its y is positive, isn't it? Be a positive y. So for this ratio, I know that my y has to be a positive number. I know that my r is always a positive number. So a positive divided by a positive would give me a positive result. So this ratio would equal a positive number for a point xy in the second quadrant. Let's look at the third quadrant. What do I know about all the x's in the third quadrant? They're negative, aren't they? What do I know about all the y's? They're negative. So for the ratio x divided by r, the x's for any point in the third quadrant would be negative, and I'll just write the little negative. Once again, r is always positive, and so if I have a negative number divided by a positive number, the result would be negative. So this ratio would equal a negative number for a point in the third quadrant. The C is a point in the fourth quadrant. Pick any point that you want. Look at its x. X is positive, isn't it? What about its y? Y is negative, isn't it? So for my x would equal a positive number, my y would equal a negative number, and a positive number divided by a negative number would give me a negative number. So the ratio x divided by y for a point in the fourth quadrant would be negative. Now, I didn't do any for a point in the first quadrant because in the first quadrant the x's are all positive and the y's are all positive, so all of your trig ratios would be positive. What function does that represent? Did you get that it would be the sine of an angle? And what trig function does that ratio represent? That would be the cosine, wouldn't it? And what about this last one? It would be the cotangent. That completes this lesson. please rewind the tape before you return it to the LRC. Thank you.